Hi, it's Moser with a quick tutorial on percent composition. After this video, you should be able to calculate the percentage composition of any element in a compound by using the chemical formula and the molar mass. You know how to do that. You already need to know how to write a formula from a compound name and how to calculate molar mass from a formula. So, percents, they're not that hard. If you get a test back and it says 62 out of 78, you know immediately how to figure out the percentage that you got on that test. You whip out the calculators and you quickly find that you got a 79.5% because you're dividing the part by the whole. The part of the points that you got divided by the whole number of points that are available. Well, percent comp is no different. Percentage composition is just the mass of the element present in 1 mole of the compound divided by the mass of 1 mole of the compound, or the molar mass, times 100%, or times 100. Whoopsie. And that gives you the percentage of that element in the compound. So let's do a couple practice problems. So for instance, what percentage of sodium chloride is made up of sodium? Well, remembering that we're looking at the part divided by the whole, we take the mass of sodium in 1 mole of NaCl and divide by the entire mass of 1 mole of NaCl. You'll need your periodic table, of course, and we find that sodium, right there, has a mass of 22.99 grams per mole, and chlorine has a mass of 35.45. So we have the mass of sodium in 1 mole as 22.99. We added up the mass of sodium chloride and we get 58.44. So when we divide those and multiply by 100, we get 39.3394% sodium in sodium chloride. 39.34% sodium. So despite the fact that there's 1 sodium ion for every chloride ion, because sodium has a lower mass, it doesn't make up 50% of the compound. Let's do another. So let's say we want to find the percentage composition of each element in glucose, C6H12O6. Well, again, start off by remembering that we're looking for the part divided by the whole. Well, if we start with carbon, that means we're looking for the mass of carbon in 1 mole of glucose divided by the mass of 1 mole of glucose. So I've added up the mass of 1 mole of glucose using the same exact method that you've been using to find molar mass all along. Now here's where it gets interesting. I know that there are 6 carbons in every molecule of glucose. So I have to take the molar mass of carbon and multiply by 6. So what do I get? Well, 72.06 grams of carbon divided by 180.18 grams of glucose times 100 gets me 39.993 blah blah blah. Well, what does it sig fig out to? Since we can only have 4 sig figs, and we're going to round this based on what comes after it, 39.99% carbon in glucose. Well, we can do this for each of the elements in glucose. So let's say we want to do the percent composition of hydrogen. Since we've already done carbon, well, we take the mass of hydrogen divided by the mass of glucose. 1.01 is the mass of a single hydrogen atom, and we have 12 of them. So we have 12.12 grams of hydrogen in 1 mole of glucose, and 1 mole of glucose has a mass of 180.18 grams. Well, what do we get? 6.72, etc. So it sig figs out to 6.727% hydrogen. Okay, so what about the percent composition oxygen in glucose? Now, you might think that it would be acceptable to just add up the percentages you've got and subtract from 100, but I'm going to advise you strongly against that. No, I'm going to demand that you never ever do that, because what if you made a mistake in one of the other two? Do each of them independently. So again, we're going to go with mass of a mole of oxygen and a mole of glucose divided by the mass of a mole of glucose. We have an individual atom of oxygen with a mass of 16 grams per mole. And we have 6 oxygen atoms in every glucose molecule. So 16 times 6 divided by 180 gives us a 96 divided by 180.18 times 100, 53.28, blah, 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 blah. And we end up sig figged at 53.28% oxygen. This is really what we're going for. We now know that a mole of glucose, or a molecule of glucose, is 39.99% carbon by mass, 6.727% hydrogen by mass, and 53.28% oxygen by mass. That's going to allow us to do some things a little later. But for now, go ahead and practice doing some percent comp problems.